So again, if you work through those sort of steps that we've been doing part A first, where you look at your non-permissible values to find out what kind of asymptotes, we always sort of factor at the beginning to set our equation up nicely, because then we can find out if we have vertical asymptotes or holes, and factoring's also going to help us figure out what our x-intercepts are. And then you go to B and look if there's any horizontal asymptotes or oblique asymptotes, and finally find your x-intercepts and y-intercepts. If you follow those steps, then you're going to see different situations, but you can figure out what to do in each of those situations just by how your graph is set up. So we're going to do the same thing here. This one's going to be an interesting one because there's going to be a hole and, looks like there's going to be a hole and a vertical asymptote. So something we haven't seen before. But it's going to make sense when we follow our steps. So I factor the bottom as a difference of squares to get x minus 3, x plus 3. So for part A, once it's factored, I know right away that I have non-permissible values, that x can't equal 3 and x can't equal negative 3. So we need to find out, are these going to be vertical asymptotes or are they going to be holes? Well, I can see that these x plus 3's are going to cancel out, which leaves my equation to become 1 over x minus 3. That means that the minus 3 is going to be a hole, and the x plus 3 is going to be a vertical asymptote. So at x equals 3, that's a vertical asymptote, because that's still a non-permissible value that didn't get canceled out. But at x equals negative 3, that's going to become a hole or a point of discontinuity. And we know the x-coordinate of that hole is negative 3. How do we find the y-coordinate of that hole? We plug it into the factored simplified version. If I do that, I would have 1 over negative 3 minus 3. I'm going to get 1 over negative 6. So right now I know I'm going to have a vertical asymptote and I'm going to have a hole. Part B. When looking at your highest powers. So notice this one is not one where we have the highest power on the top. So it's not going to have an oblique asymptote. So it's going to have a horizontal asymptote. But if we look at the highest power, either in our factored form, or in the original one, but if I look at the factored one, the highest power that's left after I've simplified it is an x. And I have one x on the bottom. How many x's do I have on the top? None. What does 0x over x simplify to? Y equals 0 is going to be our horizontal asymptote. Ha! That's how you pronounce horizontal asymptote. You can be really excited about it. I don't know. So we got a horizontal asymptote, we got a vertical asymptote, and we got a hole. Now part C, let's find our x-intercepts and y-intercepts. X-intercept. Our x-intercept will happen when our fraction is equal to 0. But once we've simplified it, can the numerator ever equal 0? No. So for our x-intercept, this one's going to have none. Our y-intercept is when we plug in 0 for x. And again, you can do that either in the original or the simplified one. Probably best to look at the simplified one because it's going to be easier since it's already simplified. If I plug in 0 for x, can you see that our y-intercept is negative 1/3? Oops. So we know that at x equals 3, we have an asymptote. We know at y equals 0, we have an asymptote. We know at negative 3, negative 1/6, estimate that. We're going to have a hole in our graph, and we know that our y-intercept is at negative 1/3. So then to decide, do we need more points or not, we're going to look at our vertical asymptote and say, do we have points to the left of it? Yes, we do. So we know this section has to approach our asymptote here, needs to go through this, and then approach our asymptote down there. We don't have any points labeled to the right of our graph, so we don't know which section to draw it in. So we're going to plug in a value, like a table of values. I'll go to my factored form here. I'm going to plug in x equals 4. Well, then I'd have 4 minus 3, which is just 1 on the bottom. 1 divided by 1 is 1. So I'm going to have the point 4 comma 1. Now that I have a point in this section, I know that it has to approach the asymptote down there and up over there. So here we have a graph that has a hole in it and an asymptote. And there are no questions to practice on this one. There might be some in the review, but none in the section.